talk about work of quite while now, but it is time to answer why did we introduce these concepts? Help us look at the world in completely different way. So let us take throwing ball hand and let's say you throw it. What's happening? Well, that ball will speed up at least your hand. Now, if you ask the question, why did the ball speed up? What is the answer? We can say, well, then you are throwing, you are pushing on it, so you put a force on it. And whenever you put a force on any, that object accelerates and therefore it speeds up. And that's why the ball comes fast. And this is the accordance to Newton's second law, which say F equal ma, which means force will accelerate. Of course, if they are, then we have calculated the net force. But we talk about this later. Let's consider only one force as now. So you are putting a force and that accelerates. That's one way to think about. Now let's think in terms of work done. You see, because you are pushing on it and you are displaying that body, you are doing work on that ball, right? And when you are doing work, look at what happens to the ball. Initially had no speed, it was at rest, so had no kinetic energy. But then after doing work, notice that it gained kinetic energy. So we can now say that by doing work and we have added kinetic energy to our boiling ball, and so by doing work, whenever work is done on an kinetic energy gets added to that object. This is a new way of looking at the same situation. Now you can also do work and remove kinetic energy if you want. For example, imagine a ball is thrown at you and you try to catch a ball like this again. Your hand will move back a little. Now think about what happened when you try to catch that ball. Your hand starts pushing, but this time it pushes in the opposite direction, and that's why it is slowing down, right? But now think about pushing it in the opposite direction to the displacement. Work done is negative. And now when you are doing negative work, look at what happened to the kinetic energy. The kinetic energy is reduced. So we can now say when you are doing negative work, you are removing the kinetic energy from the body. So negative work removes kinetic energy from the body, and this is the speaking what we call the work energy theory. This basically says when you done work, you either add it or you remove the kinetic energy from the body. If you don't do work at all, then the kinetic energy will not change. The mathematical version, of course, we have derived the mathematical version a little bit later, but before, let's look at some more examples. Let us say now you take that boiling ball and you drop it from some height. Now as we fall down, it is going to speed up. Again, let's look at work. In this particular case, gravity is pushing down on that ball, and the ball is moving in the same direction. So gravity doing positive work, and because gravity doing positive work, it is adding kinetic energy to that ball, and that's why the ball is speeding up. Similarly, if you take that same ball now and throw it up, let's say you throw that ball up. Now as the ball goes up, you might know it is slows down. Again, what's going on? We again gravity pushing down on that. Remember, gravity always puts force downwards, but this time the ball is going in the opposite direction. So gravity doing negative work, and as a result, gravity is removing kinetic energy. And what's why the ball is slowing down? This is a pretty proof, thinking in terms of work and energy. Now these things get ever more interesting when there are more than one force acting on the body. So if there are more than one force acting, according to the Newton's second law, we need to now calculate the net force, meaning we have to add it up all those forces. Well, of course, if the forces are in the same direction, we added them, and if they're in the opposite direction, we subtract them. But anyways, the total force on that pole is, and that will tell you what would be the acceleration of our body, right? Now, similarly, if there are more than one forces acting on the body, you calculate the total work done by all the forces, and now that decides what happened to the kinetic energy. So if that total work done by all the forces becomes positive, kinetic energy will be increased. Kinetic energy gets added and ends up becoming negative. That means kinetic energy will be removed. And if the total of them is zero, which is totally possible. Some forces can do positive work, and we will look at some example. The total work done can be zero, and in that case, kinetic energy will not change at all. And again, let's look at a couple of examples of that. Let's say there is a cupboard, a very rough floor, very heavy cupboard, and you want to move it, so you start pushing on it. Let us say as you push, you slowly displace it from here to here. Now, after displacing, after you push it, the cupboard is still at rest. So let's think about the kinetic energy. Initially, the kinetic energy was zero, it was at rest. After pushing also, the kinetic energy is zero. So the kinetic energy didn't change at all. So it was neither added nor removed. That means the total work done on this cupboard was zero. Why? Clearly you push on it. You did work. Then why is the work done zero? Are more than one forces acting over here? So you are pushing on it and you are doing positive work. But because the floor is rough, friction is pushing on that cupboard in opposite direction, doing negative work. So you are doing positive work. Friction is doing negative work. So it is just so happened that the two work done cancels out. Total work done ends up becoming zero. And that's why the kinetic energy didn't change. Another way I like to think about this is when you are doing, I like to think that you are adding kinetic energy to the cupboard, but at the same time, friction is removing that kinetic energy from the cupboard, and that's why the kinetic energy didn't change at all. Okay, let us do one more, which is initially at rest. It is at rest right now. I pushed it and I raised it up slowly. And finally, again, it is at rest. So even here, the kinetic energy didn't change. That means the total work done on this puppy is zero. But why? Clearly, I am pushing on it and I am making it moving. So why is the total work done zero? Can you push the video and think about this one? Well, again, I am pushing on it and I am trying to add kinetic energy to the puppy. But therefore, one more force acting on the puppy, which one? Gravity is pushing down on that puppy, and the result, because it is the opposite direction of the displacement, and gravity is removing kinetic energy from the puppy at the same time. So I am trying to add kinetic energy. Gravity is removing the kinetic energy, and that's why there is no change in the kinetic energy at all. So my positive work is cancelled out. So my positive by gravity negative work, making the total work done zero. So now that what we have some idea of the work energy theory. Let us go ahead and drive the mathematical equation for it. This will be useful for problem solving. All right, so I need to connect work and kinetic energy, right? So again, let's start with the just one force. If there one force acting on the body, then the work done by that force. The work done would be a force multiplied by the displacement. Let's call the displacement as S. Okay, what do I do next? Well, I want to somehow bring velocity into the picture because I want kinetic energy, right? And I can do that by substituting F equal ma, because that how accelerated, and then from acceleration I can bring velocity. So if I substitute F equals ma, so I will get m times s, but I don't want acceleration and I don't want displacement, I want velocity. So can you think of a connection between acceleration, displacement, and velocity? Initial velocity and final velocity. Think about, great idea to view the video and see if you are remember an equation. Well, there is an equation. V square equal U square plus 2AS. This is perfect because this will help us connect AS and write it in terms of phi of V and U. So I want to get rid of as isn't. So let me isolate this on one slide and put everything else on that other. So if I rearrange this, will get V square minus U square divided by 2. That equals A times S. Right? So now I can substitute that over here. So that will give me M times as AS is a V square minus U square divided by 2. Let us use the same U square divided by 2. And now if I open up, so what I end up with this, let us hand side is work, and that equals mv squared by 2. That's the kinetic energy, final kinetic. So we can call that as the final kinetic energy. Minus u, get mu squared by, what is the mu squared by 2? That will be kinetic energy initial. Before I start pushing, and this is the work energy theorem math. It is saying that same thing that discussed, or if you do positive work, notice the final kinetic energy will be more than. That means you are adding kinetic energy. If you are doing negative work, you are removing kinetic energy. This equation is also telling that if you do 100 joules of work as an example, then your kinetic energy will increase by 100. So you will add 100 joules of kinetic energy. Similarly, if you do 100 joules of negative work, then you will remove 100 joules of kinetic energy. So you can kind of now see what work really, when you do work on a body, what happened to that body. This kinetic energy change. So whatever work you do, that much kinetic energy gets added to or removed. And again, if there are more that are acting on the body, what happened? Now you just have to calculate the work done by all the force. So we can say this will be the total work, and or of can see this is the net work. So the total work done on a body. We decided now how much gets added or removed. And we will see in future videos that certain kinds of problems can be solved much faster by using this equation rather than F equals. Okay, so to summarize, what did we learn in this video? We learned the work energy theorem, which is basically saying that when you do positive work on a body, you added that much kinetic energy to the body, and if you do negative work on that body, you remove that much kinetic energy from the body. Of course, if there are more than one force acting on the body, then you have calculate the total work done, and that decides how much kinetic energy gets added or removed.